So we're going to look at inequalities today. So just a few things about inequalities that we need to know. First thing is, so the first rule is an inequality remains true when the same number is added or subtracted from both sides. We'll see what we mean there in a minute when I try a few examples. That's inequalities are pretty much just like algebra. We have spent a long time in algebra, and like we would have just finished off at the end of our simultaneous equations. We'll see it in our example in a minute. Okay, but just remember these two rules. I mean, the second rule, an inequality remains true when both sides are multiplied or divided by the same positive number. So our inequality should always remain positive as well. Okay, again, we'll see what you mean. We'll see what we mean in a minute. And then thirdly, we've this one down here. If an inequality is multiplied or divided by a negative number, the inequality sign must be reversed. So just remember these three things here, and we'll when we try some examples, we'll see what we mean. Now, what we need to know what our types of numbers are. So, for example, our natural numbers, remember they're counting numbers, 1, 2, 3, 4, 5, 6, all the way up, keeps on going. Then we've got our integers. They're the negative and positive whole numbers, like so all the minus numbers, 0, 1, 2, 3, 4, all the way up. Alright, so there's our integers and our natural numbers. They're two things we learned about in first year. And then we've also got our real numbers. So real numbers is everything. So it also includes the natural numbers and the integers, but everything in between. So it includes the fractions, decimals, everything. Everything and anything is a real number. So the way these three are denoted, natural numbers are denoted as n, integers as z, and real numbers as r. So if we were then to look at a number line, and let's say we have a number line like so, and let's just start a number line at minus 1, 0, 1, 2, 3. If we were to mark on this number line our natural numbers, it would be like this here. So you'd be only shading in natural numbers. Let's look at the same number line, and if we were to shade in our real numbers, or sorry, our integers I should say next. Our integers, again, same thing. I'll just mark in a few different numbers here. And it doesn't matter on your number line either, if you have 0 in the middle like I do, or if you have 3 in the middle. It just depends. We'll see when we try some examples in a minute. So if we were to mark in our integers, we'd be including minus 1, 0, 1, 2, 3, and these arrows that we just see here, 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 that means the number line goes on and on. So it's just like a number line you would have had in first year. And then of course finally we'd have our third type. We'd have our real numbers. And again, I'm just going to put 2 in the middle here just to mix it up a little bit. 1, 0, minus 1, and it goes on and on and on. Well, for our real numbers, because it includes everything in between these numbers, so it actually shade in the whole line. Okay, so now we're going to try some examples and we'll see where we use this. So we've got our three signs here, as you can see. This one greater than, this one less than, this one greater than or equal to, this one less than or equal to. So you'll see what way they are actually pointing. This one's pointing towards the right, so all the numbers that are greater than a certain number. This one is pointing towards the left, so it's less than a certain number. Do you see the only difference here between the greater than or equal to and the greater than is this line underneath it? And then here we've got the less than or equal to. So let's look at our next slide. And we can see that if we had x is greater than 5 and x was a natural number, remember what all the natural numbers are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up. But these are where x is greater than 5. So what numbers are greater than 5? Well, 6 is, 7 is, 8 is, and so on and so forth. So that's exactly what we'd mark. We'd mark all the numbers that are greater than 5 and are also a natural number. Now, if that had said, let's say x is greater than or equal to 3, well then, and I'll just do another number line here, and it was x is an element of the natural numbers. I'll just go natural numbers again. So I'll just put 3 in the middle. So you can probably see that I haven't put 0 in the middle of these. There's no need to put 0 in the middle of these. You can do them as long as you like, the number lines. I'd always just see whatever number I'm left with here at the end, and I'll do my number line from there. You'll just find it's a lot easier. Anyway, x is greater than or equal to 3. So now you can see it actually has equal to. Okay, so it has the equals to or greater than. So what numbers are greater than or equal to 3 and are also a natural number? Well, we've got 3 is. That's greater than or equal to 3. 4 is. 5 is. 6 is. And so on and so forth. So now we're going to try our example. So we can see here we're asked to solve the inequality 3x minus 4 greater than or equal to minus 5. Hence, graph the following solution sets in the number line. 3x minus 4 greater than or equal to minus 5, where x is a natural number. 3x minus 4 greater than minus 5, where x is an integer. And 3x minus 4 is greater than minus 5, where x is a real number. So you see the only difference between these three is one's natural, one's integers, and one is real. Alright. So let's try and solve this one. Just try and solve it like algebra. And what we do is we treat this greater than or equal to sign. You can see it's greater than or equal to. We treat this just like we treat an equal sign. So anytime you bring anything across an equal sign, remember we always done the opposite. So we brought a plus across, it became a minus across, it became a plus. It's the same as a rule. It's pretty much what the rules on the first slide of this said. So let's try and solve it first of all. So we have 3x minus 4 greater than or equal to minus 5. And this is the same for all of part 2, part 3, part 4. Okay, we have to solve it first and then we can actually put it on the number line. So let's solve. We always try and keep our x on the left hand side, like so. And of course, what happens to this minus 4 when it goes across an equal sign? It becomes a plus 4. So the same rules are actually applying. So now I have 3x greater than or equal to minus 5 plus 4, which is minus 1. So now what we do is we want to try and find what x is, of course. So x greater than or equal to, this 3 at the moment is 3x, and what happens, it's multiplied of course. What happens to multiply when it comes across? It becomes a divide. Now this is a difficult one, because look, I've ended up with a fraction, and that's what I'm basically looking for at the end of all these. I'm looking for an x is greater than or equal to a number. Okay, now this is actually a fraction I've got here. Normally you don't get fractions, normally you get whole numbers, but I just picked a real difficult one to start off with. So let's go first of all and do now part 2. So we've solved the inequality. Now we have to draw it out on a number line when it's a natural number, then when it's an integer, then when it's a real number. So let's do it first of all when it's a natural number. So you can see it's x is greater than or equal to minus 1/3. So let's draw out our number line, like so. And first of all, we're going to go where x is a natural number. So I'm just going to put 0 here in the middle. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Now, minus 1/3, that would be probably around here in the number line. But we have to put it when it's a natural number. So it's all the numbers greater than minus 1/3 that are natural numbers. Well, 0 is greater than minus 1/3, but that's not a natural number. 1 is a natural number, isn't it? So we can actually shade in 1. 2 is a natural number. We can shade in 2. 3 is a natural number. And 4. So these numbers here are all greater than minus 1/3. And this just means it goes on and on and on. Let's do it now where x is an element of the integers. So x is an element of z. Again, got to put in my number line, like so. 4, 1, minus 2, minus 3, minus 4. And again, you probably remember we just said minus 1/3 would be probably around here. We're looking for all the numbers greater than minus 1/3, which are integers. So, well, 0 is an integer, isn't it? And it's greater than minus 1/3. So we shade in 0. 1 is also 1. 2 is also 1. 3 is also 1. 4 is also 1. And it goes on and on and on. Next, we're going to do our last one, where it was a real number. So again, draw out my number line. So 0, 1, 2, 3, 4, 5, minus 1, minus 3, and minus 4. So now we're going to do all the numbers greater than minus 1/3 that are real numbers. So, well, minus 1/3 is a real number. And that's around there. And then remember, the real numbers are everything. So everything that's actually in between 0 and 1, 0 and minus 1/3, between 1 and 2. So what we do then is actually just shade in the whole line. And that's it done. And there we've now solved the inequality. So that example there you could see, and I'll just go through it one more time. We solved it first of all. We solved it like algebra. So we're left with x is greater than or equal to minus 1/3. Now in a lot of these you'll get x is greater than or equal to 2, x is greater than or equal to 1, and so on. This one here is a little bit more difficult, so it's x is greater than or equal to minus 1/3. You saw on the previous slide how we done that. And then we had to show that was when it was a natural number. So remember, natural numbers are just our counting numbers. So all the numbers that are greater than minus 1/3, which is here. Then it was an integer. All the numbers are greater than minus 1/3. Then it was a real number. All the numbers are greater than minus 1/3. And that's what we're going to be doing today.